I can't remember which one it was. Let's see. Real quick though, while I'm thinking about it, anybody need a blank copy of the practice test? Anybody need a copy of the answer key? Oh, it's test one, shit. Where's test two? Oh, where's test two? Sorry, guys. Yeah, it's like YouTube. Alright. Okay. It was number 1I. Feel like a lawyer.
Subsection J, paragraph 2.
What's up? Better call Saul. Help me go. 1I, a plus 6 got left off at the end. So, let me show you. And don't forget, do the practice test if you have time, and then check it out against the answer key. And then if you make mistakes, go back and review those. You don't have to do the practice test at all if you don't want to. And also, this is not something to learn from. I didn't write anywhere near enough little notes and stuff to learn from this. This is just something to check your work against. When the copying, something didn't get copied down. Oh, you already got it here, Chad. So here on whoa. All right, Jeff. All right, holy crap. One of these is zoom, and the other one is brightness. There you go. All right. So right here, see how this is 6 cosine squared and 6 sine squared? So what got left off here is there's a plus 6 off the edge here. So it should be because 6 cosine squared plus 6 sine squared would be 6. Cool. So there's a plus 6 right there. Cool. It's just a little too far over for the printer.
Which number is that?
1I. Problem 1, subsection I. All right. So what you got? What do you want to focus on?
Can you do homework? I have like a couple of questions.
Of course.
3.469.
Ooh, yeah. So they set up for us, and 3.469, it says little f is differentiable in R. On all the real numbers, that's what that means. Big ass f, let that be, define big ass f to be f of e to the x. Where is this differentiable?
Everywhere.
Everywhere, I love it. If f of x is differentiable everywhere, that's differentiable everywhere. And then define big ass g of x to be e to the f of x. Is that right, Jeff? Yes. So then it says, what is f, big ass f prime? So how would I do big ass f prime? So this is one of those, gets to the idea of the process, but it's, you gotta, is there an inside function and an outside function?
Yes.
Yes. What's the inside function?
Function X.
E to the x. What's the outside function?
F.
F. So what rule am I going to use? Is this f times something?
Chain rule.
Chain rule. It's something inside of another function. It's not a function times a function. So it's sort of like the difference between this and this. Even if I put them in parentheses. Which one is chain rule? And which one is product rule? The bottom. This is a product of functions. This is a function of a function. Tangent, trig functions definitely get you guys. This don't mean shit. It's like saying, all right, do that. It's not even zero. The answer is not zero. It's empty space inside. What's the square root of empty space? What would the universe look like if it wasn't there? No, okay, well, holy shit. That's not good. So symbols by themselves don't mean shit. So this is a function of another function. So I want to use chain rule, which says to do what? What's chain rule say in English? It says take the derivative of the outside. So what's the outside function? F. So the f prime of stuff times
The inside.
derivative of the inside, which is easy, too easy. I'm not even going to write the rule. Just put it down. Derivative of the inside is e dx, right? So up here, f was the outside function, e to the x was the inside function. On big ass G, what's the outside function? E. And what's the inside function? All right. I'm going to let you guys finish that one out. So see, there's a reason, there's a purpose for the problems. It's just not always immediately obvious, but do you see how they're just making sure you understand? Same function, just composed in a different order.
And 75, should we do it?
Ooh, I love it. 75. You're not going to like 75, but
No, it's going to be long, I know.
I have to give you one of those just to show you that, this kind of thing exists. But anybody have to go to something called differential equations? Do you know if you have to go that far? All right, so this is a little bit of a taste of that. Thankfully, it's not all this, but this is checking a solution to a differential equation. What the hell? We're not going to learn differential equations, but they say, show that this... Shit, where'd it go? 70 what?
75.
It's 5, okay. Show that this is a solution to this y double prime minus 4y prime plus y equals 0.
That was such a long problem.
Totally. Thankfully, I didn't give you more than one of those, right? But I'm not going to give you a lot of this kind of thing, but I have to throw this in every now and again. Because this is all about keeping things organized. I mean, and math sometimes becomes that. So you just have to have that skill. This will be a long problem. I will, you just heard it from somebody who survived it. So, but how do you do it?
First derivative, second derivative.
Yeah, you already know what y is, so you're going to plug that there. Take this guy's derivative and plug that there. Take that guy's derivative again and plug that there. And then just show that it equals 0. So a lot of shit, everything should cancel. Somehow. Alright. So I didn't just give it to you to be mean. Some other problems I gave you to be mean. That problem I gave to you, that's not true. Sure. Just to realize that sometimes that's what it takes. I don't like giving you busy work. I don't, but that's a skill, is keeping track of things as you go through a problem. And just to let you know, this kind of thing exists. It's kind of neat. This is a relationship between different levels of derivatives. There's an equation made out of derivatives. That's incredibly enough, that's what differential equations is all about. And this is what real life level science is about, is the rates of change of things and how they're related to each other. Okay. Yes, sir?
45.
Oh yeah, cool. So I don't know if the comment I made before about Russian nesting dolls, did it make sense? Nope. You know what the Russian nesting dolls are? Yeah. You have this big one, and there's a little tiny one, you open it, and there's a tiny one, open it, there's a tiny one, and you're like, when the hell is this stop? Shit. Or you don't do that at all. This one's got a few layers to it. Number 45. Cosine of square root of sine of tangent of pi x. Every time I said of, there's another level. Right? Okay. Yeah, so a good first step is just to rewrite that radical. So it's cosine of sine of tangent of pi x. And this is to the... Let me see, how many levels do I need on this? This is to the 1/2. The sine stuff is to the 1/2. Okay. This is nowhere near as long as that problem, but it is semi-long because you're going to have several links on your chain, right? So let's do the first couple steps.
Minus sine.
Good. The root of cosine of shit is negative sine of shit, right? But then I have to do what?
Keep it inside.
Times so it's not a bad idea. So you don't keep writing this and this over and over and over again. And by the way, this is I got to be real careful. People make the mistake. What is the sine of? Is it? I mean, not say anymore. Sine of what?
Everything that's inside of there.
Sine of this. Right? So to make that really, really clear. So it'd be the derivative of cosine of stuff is sine of stuff times, so that this is multiplying the whole thing. It's not inside of this first sine. You guys understand this? How the chain rule works, period. It takes the inside function out and takes its derivative. So it's multiplying by the whole, whatever you got so far. So what I would suggest you do is you can do this, get it done by itself, and then bring the answer back in. You can do that if you want to, or you just keep rewriting this until you go insane. If you haven't already, join us. And you're all like, you joke, but I'm on the edge. All right. Are you guys understanding what's going on? Now it's easier because now I got less shit to look at, right? What's the next level to worry about? Good. So 1/2. So the 1/2 will come down. That will go to a negative 1/2. All this stuff remains the same on the inside times. Now you take the derivative of the inside.
Where does it start?
It doesn't.
Somebody's still doing it from a few years ago. I go and check on them every now and again.
Is he in your basement?
No, we have a padded room over here for some select students.
That's why there's some missing room numbers, huh?
Yeah. Oh, you're not supposed to figure that out.
Oops.
Yeah, it was too much.
We have another room for that. 2 for lunch. All right, I'm sorry, Jeff. You're all like, yeah, you joking, Jeff, but this is not making any sense to me. Yeah. In the same section? The E negative 2t, that thing? Right. So so bring out what they want from this. That's all I'm going to do for you. It's not done. It's nowhere near done. This problem, I'll warn you now, this is the kind of problem I would want you to do several derivatives of. This one just wants you to find the first derivative of this. Where'd it go? 14. So maybe I got to start using this notation a little more often. It's going to become more important here soon. So whenever I write y prime or f prime, I could write df, d, whatever the variable is, right? And that notation comes in very handy, especially when you're talking about units. But you can always use it. It's just two competing ways of writing the same thing. Like I told you before, this would mean dy dt. This would mean couple derivatives of y with respect to t, so forth. Right? In physics, we use the dots a lot, and that's a whole other notation somebody else came up with. So what's the main thing about this? The main rule that I need to use? Product. It's a product of two functions. That's the main rule. Inside that rule is going to be some stuff, but who gives a shit? I don't have to know that at first. I just do it as it comes, right? The main thing I need to worry about is there's two separate functions that are multiplying. I've got to use the product rule. What's the product rule say? Yeah. Get rid of this times that. Then this guy gets a turn, right? Go ahead. So get rid of this times that plus that times the root of that one. They each get a turn. Yeah, and then that's not too bad, right? Do you remember the shortcut for this one?
Split them up.
Yeah, there's a -2 that comes down, sort of. The inside is linear. So when you do derivative of e, it's e to that times the derivative of this. Well, the derivative of this is -2 because it's just a linear function, right? It's going to be its slope. Cosine 4t. And what's the derivative of cosine 4t?
Negative sign.
4 minus sine.
Yeah, it'll be negative sine times the derivative of
Outside.
4t, which is the inside is 4t, so it's going to have a chain rule piece that shows up.
What is that sign of what over t? Wow.
Your derivative of cosine 4t is basically sine 4t, right? Negative sine 4t, but times the derivative of the inside, which is 4. Same way the derivative of that inside is -2. Same reason. They're both linear, so you can see their slopes. Yes?
3.466. I just want to know, is that the same concept as in 69?
On the first step, yes.
Yeah.
And so it's like 69 with one extra step. You can actually figure out what it is. You can estimate what it is from the graph.
Okay.
Yep. But if I told you that h of x equals f of x, and everything in there is differentiable, what's h prime of x equal to?
F prime, f of x,
F prime of stuff
and
times f prime of x. I like it. So the outside function, and then the inside gets a turn. And then they give you a graph of f of x. So they ask you what is h prime of 2. Well, it's going to be the derivative of f of 2 at f, right? You got to figure out what f of 2 is. Look at that point on the graph and estimate its slope at that point times the slope at 2. So it's like one extra level. So it is sort of like 69, first step, and then the next step is you can actually figure out what the number is. You can estimate what it is. Because they give you a graph.
yeah.
Okay.
Well,
12? In 3-4, I guess?
yes.
Okay. So that looks a lot like one we just did earlier, but more specific. So this one's got sine of e to the t plus e to the sine t, right? Yeah. See how they switch inside function, outside function switches? Do you guys see that? So it looks a lot like that one we did earlier. What's the outside function on this first part?
Side of stuff.
Sine stuff. So what's the derivative of sine stuff? Cosine stuff times the inside derivative. Right? And then this looks like e to the stuff. What's the derivative of e to something?
E to the stuff.
Itself. Times the careful. Derivative of sine t is cosine t. That's really not much you can do with that. You can't factor anything out. Yes?
20. Would it be better to apply product rule or quotient rule?
That is totally up to you. And actually, this is a good place to show you. When I first learned, just to do a different problem for a second. When I first learned quotient rule, I hated it. I hated it because my teacher wasn't very clear on why things were the way they were. Now I know it's on the bottom. It's the part that's got a minus sign because it was on the frickin' bottom. So it's going to have a negative power. Now it makes total sense, of course, thankfully, or else why would I be here in front of you? Alright, but when I first learned this, I hated quotient rule. I never used the quotient rule. I just brought the bottom up. So this is what you're talking about, right? So you're thinking about maybe taking that one and rewriting it. So you could totally do that, sure. You could take that second one and bring it back down and make it into a quotient rule. Why the hell not? Totally. But now I can just apply the product rule, which is completely unambiguous. I don't have to know which ones. Now I got my little song. Top first, and then hopefully some of you guys might realize. Normally you remember the form of the quotient rule. Several of you just did it out of order. But all you need to remember is top first. Take the derivative of the top first. Some of you guys know exactly what I'm talking about because you did the other way on your quiz. So if I do product rule here, derivative of the first one is 1. Plus, leave the first one alone. What's the derivative of this one? Whatever. 2,000 times 3. I like it. So you get 1 over 3x plus 5 minus 3x minus 3. Is that cool? Over 3x plus 5 squared. And if I wanted to, I can get LCD and put them back together. That's where this process actually loses out the quotient rule. Do you see now why the bottom is squared in quotient rule? Because I have to make an LCD, so it's going to be that squared. Because one of them is going to be negative 1 power, so now it's going to be negative 2 power. See how it all comes back? So the quotient rule has the squared thing built in. It already has them put back together in one fraction. This method, you have 2 separate fractions that if you have to, you have to actually put them together yourself. Ooh. Right, so it's up to you. I could have done this whole thing from the beginning as a quotient rule problem, right? Do you guys see that what I'm talking about?
Yes.
So this is an option that I actually now strongly recommend you don't do. Right, sometimes it's better this way, sometimes it's better the quotient. You might as well just do quotient rule so you remember it too. Right?
I just get lost in simplifying it.
But no, same time I say that, this is all about taking math and making it your own. This is always valid. Right? Always valid. You can always do this if you want. It's just, you get the extra little thing about getting the LCD. That should be a big deal. Right? Okay. Anything else?
Can we do 1H from the practice test?
Alright. I thought we did something with that already. By the way, while I'm thinking about it, if I said take the derivative of this, I just had, if I had one person do this, I'm like, all right, it's that person. I had like 4 or 5 people do this. If I say take the derivative of this, and the first thing you do is this, you have changed the problem. You can't get it right now because you're taking the derivative of a function I didn't ask you anything about. That is not the same function as this, right? You guys with me?
Yes.
So that relates to, I think it was 1b. Several of you decided, you said, that's a nice function you've given me, Jeff, but I don't like it. I'm going to do this one. And I'm not saying you did that on purpose, but it's effectively what you did. When you put parentheses in that aren't there, you're changing the order of operations. It is now a different function. So you can never get the answer right. Oh, man. Anyway, sorry. So that's a little thing. Several people did it. So I was like, oh shit. If I do this the way it's given to me, and it was f of x and blah, blah, blah. If I do f prime directly off of the way it's written, what rules am I going to have to use? There's a rule I don't even know yet. So maybe that's why you asked. What's the derivative of natural log? We don't even freaking officially know. I know some of you know. That's nice. Ooh. I'm sorry. Right? It's just a fact. You know, a fact. Ooh, big deal. We got to still prove it. We got to prove why it is what it is. We haven't done that yet. So officially, to me, you don't know it yet. Right? So how could that be? How could that be a fair thing to do to you? You're like, you gave me a natural log thing, Jeff. No, I didn't. No, I didn't. It's just numbers. What's a rule of any log? What can I do with the powers of any log? Bring it down. Now that's ln of 3. That is a number. You don't have to know ln's derivative rule anyway because that's a constant. It's a coefficient. You don't need it. And one extra little thing I think I did on the answer key was I brought that 2 up just to solidify it a bit, just so I wouldn't have a 2 floating around. The same way that can come down, that 2 can go up, can't it? You don't have to write it, but I did like this on the answer key just to put that stuff together in one place. So I got less shit to worry about. And now, how do you do the derivative of this? No product rule required. I have a single function. I have a function inside of that function, so I'm going to need chain rule. But I have a constant times a function. That's not a product rule. It's not a product. In fact, if you did do like this as a product rule, wouldn't this be 3 prime x plus 3x prime? Well, what's 3 prime? 0. So why waste your time? And that's why constant coefficients don't cause it to be a product rule, because they would make that part 0. So why write it down? You guys kind of with me? So a few of you guys kind of got lost in that, making too many things product rules that didn't have to be. The only product rules are the product of true functions. X explicitly shows up. So what is f prime going to be then? What's the derivative of tangent? Secant squared of stuff times the derivative of stuff. If you let that, that'd be alright, but you can collect your coefficients out front, but it doesn't really make it any better. Why did I just do that? Was that on the
Practice.
practice test? Oh, good. Alright. Yeah, good. That was on somebody's quiz.
That's it. Just pull the 5 out front, right?
Can you multiply the 9 into 5?
No.
No. You can't bring a 5 inside of a log, right? So you could do this, 5L, right? Bring those out front. And then if you really, really wanted to, you can bring that 5 up here and make this natural log of 9 to the 5th. All that crap doesn't do anything for you. So if you do it, yay. If you don't, no problem. Yeah.
Number 2.
For you guys, real quick. I mean, if I had a 3 out here and you stop there, I'm going to have to say something at least. Right? Should put 15 there. I mean, do simple simplification. Some of you guys had like 3 over 6 and you were leaving it 3 over 6. I'm like, holy shit, that's math 88. You see 3 over 6, you make 1/2. I don't care what level of math you're at. Right, some fractions are beneath me. Shut up. Oh, sorry, which one?
2.
So on this one, I know I'm eventually going to want to do what? If it says find where the tangent lines are horizontal, I'm eventually going to do what? Take the derivative and set it equal to 0. Which means my derivative, I'm going to want to factor it. That's what it's going to make the equal 0 part easier, right? So this is exactly the problem that kills people in Math 178. What's that got to do with you? I don't know. Just telling you. It's always algebra that kills people. Right? I'm not in algebra class anymore. Well, there was a reason you took algebra class, because guess what? It's everywhere. So, how do I do this derivative? What's the main thing happening?
Chain reaction.
That's not the main thing. The main thing is product rule. It's the most excited whenever I ever pretend like it was directed to us. Yes, chain rule, product rule.
Product rule, yeah.
That's the level we should have taken.
Above and beyond.
So what happens here? So
Take the derivative of that.
Yeah.
derivative of that. So I get 2 times x minus 5 to the first. The inside derivative would be 1. It's linear with the slope of 1, so it doesn't even have to worry about it, right? Plus, leave the first piece alone, and then take derivative of this guy. What's going to happen there? 3 is going to come down. Good? And the derivative of that is 3. I like it. Whenever the inside of what you take derivative of is more than just x, chain rule is going to show up. Chain rule is always here, remember that. Because if the inside is just x, it's times 1. Derivative of x is 1. Alright, so chain rule is always there. When's it going to show up? When the inside is more than just x. So then how do I factor this? Let's go ahead and make that a 9. Is that cool? Bring that 3 out there. Combine those 3's. Now how do I factor this to get ready for setting it equal to 0?
Take out one of the x minus 5.
Yeah, take out 1 x minus 5.
And then take out 2 of the 3x minus 2.
Take out 2 of these.